Welcome students. We already completed chapter 1, 2, 3, 4, 5, that is two different units. Chapter 1, 2, 3 were about web designing, creating HTML form and CSS and JavaScript and all this thing. And chapter 4 and 5 were about e-commerce and m-commerce. Now moving over to new unit of textbook, that is chapter 6, 7, 8, 9, 10 and 11. These 6 chapters are about Java language or object-oriented programming language. So object-oriented concept, chapter 6 discusses about all the basic concepts of object-oriented programming language. Chapter 6 is not discussing anything about Java language rather, but it is just discussing about what is object-oriented concept. So let us begin. In the era of internet, websites and web-based operations, rapid application development and reusability of source code is very important. So just creating a base for what is object-oriented programming and what are the advantages, why we need object-oriented programming. So now it is like at present, in the era of internet and website and even web-based all applications and operations, we need to develop such applications which can be developed very rapidly, and reusability of the source code is also very important. Object-oriented technique as methodology or paradigm is playing significant role in analysis, designing and implementation of system software or software system. So object-oriented programming technique is playing very important role for analysis, design and implementation of software system. Software designed using object-oriented method are said to be more reliable, easier to maintain, reuse and enhance. So the software which we have designed using object-oriented method, they are more reliable, very easy to maintain, very easy to reuse again and again, and to enhance from the existing code. So that is what the concept of or introduction of object-oriented programming. So object-oriented programming concept started in 1960s, and since mid 1980s it had become the main programming method used in the creation of new software. These years are given in textbook, that is in 1960 when the concept started, and by what time it became the main programming method, that is 1980s. Remember that for the exam point of view, board exam point of view. Object-oriented programming was developed to handle the rapidly increasing size and complexity of software system. So like what was the reason why object-oriented programming concept started? So the main reason behind that was to handle the rapidly increasing size and complexity of the software. See, as hardware started enhancing, previously there were only monochrome monitor, then grayscale monitor, then color monitor, then true color monitor, LCD monitor, LED monitor. Previously computers were coming with very less memory, 1 MB memory, then came with 1 GB memory, then 4 GB RAM and so on. So to handle, and why all this development, is the development was of hardware, so the development of software also. So previously softwares were very simple, but nowadays softwares are having very complex and high graphics in their display or in the output. And to handle this, we need a programming technique which can handle all these things very easily. So to make it easier to modify this large and complex system over time, object-oriented programming was used or being used. C++, Java, VB.NET, ASP.NET and PHP, these are some object-oriented programming languages. Now programming categories. How many types of programming categories are there? If there is object-oriented category, is there any other category also? Yes, so there are basically two categories of programming. The way programming can be divided are into two categories: structured, or it is also known as procedural programming, and second is object-oriented programming. Structured or procedural programming, in this focus is on writing functions or procedures or methods which operates on data. So for example, library application software may contain modules like student registration, book issue, book return, etc. So here the focus is on writing functions or procedures. Whereas in object-oriented programming, the focus is on object, which contains both data as well as functionality. So both are together written within the that object, and that object contains both data and functionality together. So for example, association between objects like student returns book. So over there, the data is also contained and even its functionality is also contained together. So that is object oriented programming. Here the focus is on object, and that object contains both data as well as functionality. Whereas in structured or procedural programming, the focus is on writing functions or methods or procedures. Power of object-oriented programming. What object-oriented programming can do for us. So the power of object-oriented programming language enables the programmer to create modular, reusable and extendable code. Now this is very interesting to understand. Modular code. Modular code is a kind of programming where different modules are prepared by different people and then they are brought together to make one software. So that is modularity. Reusability or reusable means if you have written some code and the same code if you want to use somewhere else in your program, you can reuse that code without writing that code again. So that is reusability. And extendable code means if you have written one code and the second code which you want to write contains everything which you have written in code A and code B contains everything which you have written in code A, then you can extend that code A into code B and then add new things in that. So that is extendability. So object-oriented programming language enables its programmer to create modular, reusable and extendable code. Programmer can formulate program by composition and modification of existing module. So you have so many modules written and then you can have composition or modification of these existing modules in different ways to create different programs. Flexibility is gained by being able to change or replace modules without disturbing other parts of code. So we get flexibility where we are being able to change or replace modules without disturbing other parts of the code. So if you understand this modularity, modular kitchen if you know. So modular kitchen is where different things are manufactured or prepared different place and then they are brought at one place and then over there it is brought together to make one final product. And the advantage is what we can do out there is we can make some changes in one module without disturbing other part of the program or the code. So that is flexibility. Software development speed is gained by reusing and enhancing the existing code. So we get the software development speed because the same code if you want to reuse somewhere else you don't need to write it again and you can enhance the existing code. Object oriented programming uses object as its fundamental building block. Similar objects are classified using a concept of class. So in object oriented programming it uses objects as its fundamental building block and similar objects are classified using a concept of class. We will discuss this topic in detail further, that what is the class and the relations between objects. A computer language is object oriented if they support 4 object properties called abstraction, encapsulation, polymorphism and inheritance. Now what is the meaning of all these 4 properties? of object we will discuss further in this chapter, that what is the meaning of abstraction, what is the meaning of encapsulation, meaning of polymorphism and inheritance. We will discuss in detail in the same chapter, chapter 6. Moving over to next topic, what is an object now? Then, so in the real world, objects are the entities of which the world is comprised of. There are two types of object, concrete objects and abstract object. Concrete objects are like car, table, etc., where we can see that, we can touch it, we can feel it. Abstract objects are like date, time, which we cannot touch, but we can feel it. So that is abstract object and concrete object. All objects have unique identity. Every object has unique identity. For example, a person may have identity like name, gender, profession, address, birth date, etc. Such characteristics are known as properties or attributes. Now this is something you need to remember now. That what are the properties of an object? So the properties of the object are like the thing which gives unique identity to that object. So that is called properties or attributes. So what are the things that gives unique identity to us? My name, my gender, my profession, my birth date, my address. These are such things which gives unique identity to me. Otherwise, I am a person, you are a person, everybody is person. So person, person, person is common. But then how one person differs from other person? So by their name, their gender, their profession, their birth date, their address and other things. So these are the things which are known as properties or attributes of object. We use values of these attributes. So values of these attributes means values of name attribute, values of gender attribute, values of profession attribute, values of birth date attribute. So we use values of all these attributes to distinguish them, and these values are called state of the object. So there are many things now in this slide. First, what is an object? So in real world, objects are entities which the world is comprised of. There are two types of object, concrete objects and abstract object. Every object has a unique identity which are known as properties or attributes, and the values of these properties or attributes are called state of the object, and each object differs from one another by the state of that object. My name is different, my friend name is different, my birth date is different, my friend birth date is different. So these are called state of the object. So state of the object are something which gives unique identity to each and every object. More about object. There are some behaviors associated with objects. Previously it was about properties and attributes. Now it discusses about behaviors. So there are some behaviors also associated with objects. For example, person takes birth, gets name, changes location, all these things. The behavior is also known as method or function. You can call whatever you want to say, method, you can call functions, you can call behaviors. State of the object can change due to its behavior. This is something very interesting to understand. State of the object can change due to its behavior, because behavior is what? So behavior is something which is associated with object. So behavior is used to change the state of the object, that is the value of the object. So value of object, that is properties, as you see here again. Properties of the object, and that property, every property will have some values. So values of the object, that is state of the object, can change due to its behavior. Thus, any real world object can be described in terms of what it is called, that is its identity, what it is, that is its state, and what it does, that is its behavior. So any object can have three things: the name of the object, that is identity, what it is, that is its state of the object, and what it does, that is its behavior. In object oriented programming, Attributes that describe the object are also referred to as data fields. So remember, attributes that describes the object are also referred to as data fields. The data attributes and behavioral methods associated with an object are collectively referred to as its members or features. So now this thing, the properties and attribute and behavior, as we discuss here in this slide, both together or collectively are known as members or the features of the object. So members of the object or features of the object means the attributes and behavior. So that is state and behavior of the object. Together, collectively, they are referred to as its members or features. As you can see here now, we will be discussing about class and object now. So here as you see, this is person class. Person class contains 5 things, that is name, city, gender, birth date and profession. Now all these are objects of person class. All these are objects of person class. As you see, they have same information, that is name, city, gender, birth date and profession, but they differ in their values. That is the state of the object. Now as you see, the first object, the name is Miss Dana, city is Rajkot, gender is female, birth date is 9992 and profession is hockey player. Similarly, Professor Shyam, city is Ahmedabad, gender is male, birth date is 2775 and profession is professor, and so on. So as you can see, person class has got common attributes which are shared by all the objects, but then all these objects are differing from each other by the values of that object. So the value, that is the state of the object, differs from one object to another object, which gives that object a unique identity. So what is a class now? From this example of object person, it can be seen that various objects possessing same characteristics and behavior differ only in the state, that is value of the data. They are all same, all the 5 are same. They are only differing in their values. They are only differing in their values. That values of name is different for all, city is different, birth date is different, profession is different for all these objects. Object-oriented system uses the concept of class that enables to express the set of objects that are abstractly equivalent, differing only in its value. So object-oriented system uses the concept of class. So this is a class, person class, and that enables to express the set of objects. So you can see set of objects, there are 5 set of objects that are abstractly equivalent. So as you see, they are abstractly equivalent, they are same, name, city, gender, birth date and profession. So they are abstractly equivalent, differing only in the value of the attributes. They just differ in their values of the attribute, that birth date of first object is 9992, second object is 2775, third object birth date is 22/2/99, fourth object is 11/11/90, and fifth object has got 15/5/85. So as you can see, they are just differing only in the values of the attributes. So a class can be considered as a blueprint for various objects of similar type. It just gives a highlight that how the objects will be and what that object will contain, and then each object will have some different values. So a class can be considered as a blueprint for various objects of similar type. Similar type is very important because from one class you may create as many objects. Here there are 5 objects. You may create as many objects you want to create from class person. This class person, you may create as many objects you want to create. Here it is 5. You may create 500 objects, but they are having same information. So you can't have object from class person where there is address field, because in the person class there is no address. So object cannot have that. Object can have only those informations which are defined within the class. So that is, a class can be considered as a blueprint for various objects of similar types. So a class is a template for multiple objects with similar features. The same sentence in little different meaning, different words and sentence it is given. Otherwise both are same. So remember, both are given in textbook. So you need to remember that a class is a template for multiple objects with similar features. A class describes a group of objects with similar attributes and common behavior. So this class defines group of objects, all these objects with similar attributes and common behavior. A class is a general concept used to embody all the common features of a set of objects. The same thing textbook is giving in different sentence formation. So for example, a class named person is describing common attributes and behavior of all persons, and then individual persons are then objects and are identified by its state, that is the value of their attributes. So all these are called state of the object. Miss Dana, Professor Syam, Mr. Abhay, Miss Bina, Dr. Meera, all these are called state of the object. So they differ in the state of the object. So that, for example, I can name person class describing common attributes and behavior of all persons, and individual persons are then objects and are identified by the state, that is the value of their attributes. Next is, what is a class diagram? A class diagram presents a collection of classes, constraints, and relations among different classes. So a class diagram is used to represent collection of classes, constraints, and relation among different classes. UML, that is Unified Modeling Language, can be used to create models of object-oriented software to help with design of an application. So now what is UML? UML is Unified Modeling Language. It's not a computer programming language. It is a language which is used to describe object-oriented concept on paper, like flowchart. If you know about flowchart is for structured programming, and then for object-oriented programming, if you want to describe something on paper, then we use UML, that is Unified Modeling Language. It can be used to create models of object-oriented software to help with design of an application. UML is a visual modeling language defined and maintained by Object Management Group, that is OMG. So you have now new full form of OMG. It is not oh my god, rather it is Object Management Group. UML specifies several diagrams to represent different aspects of a software application. So it's as I said, UML specifies several diagrams and some symbols which are used to represent different aspects of a software application based on object-oriented concept. Now, what is the purpose of class diagram then? Why we need class diagram? So the purpose of the class diagram is to model the static view of an application, static view, so that it's on paper and it has a static view of the application, so that anybody who wants to develop any software can develop that software from that static view of the class diagram, and whichever language he or she wants to follow can follow. A class diagram are the only diagrams which can be directly mapped with object-oriented language. So a class diagram can be directly mapped with object-oriented language. As flowchart can be directly mapped with structured programming language, class diagram can be mapped with object-oriented language. Class diagram is widely used among software developers. So software developers are using class diagram to represent class on paper using UML, that is Unified Modeling Language, which is managed and maintained by Object Management Group. So how a class diagram is represented? So in class diagram, a class is represented with an icon using a rectangle split into three different sections. And all these three sections names are name of the class, attributes of the class, and behavior of the class. Name of the class is in the top section, attributes or properties or variables of the class in the middle section, behavior or operations or methods or functions of the class in the bottom section. So it's like this. This is a class diagram where a rectangle is split into three parts. The first part on the top is name of the class, second is the attributes or variables of the class, and third is the behavior of the class. So this is what a class diagram. So today we discussed about what are objects and class. We took this introduction of object-oriented programming when the concept started, which are the popular object-oriented programming languages, how many types of programming categories. There are two categories of the programming, that is structured or procedural, and other is object-oriented. Then power of object-oriented programming, it is modular, reusable and extendable code. It can be composite and modified easily with the existing modules. Flexibility is there, speed is there, and all those are the language, object-oriented language, if they are supporting abstraction, encapsulation, polymorphism and inheritance. Then we saw what is an object, two types of object, concrete objects and abstract object. All objects have a unique identity and it is some characteristics which are also known as properties or attributes, and the values of these attributes or properties are used to distinguish all objects from each other, and that is called state of the object. Then we also saw that object can be described in terms of what it is called, what it is, and what it does. That is the name of the object, state of the object, and behavior of the object. Then what are members and features? So the data attributes and behavioral methods associated with a particular object are collectively known as members or features. Let me quickly take you here back. So this two part, second part and third part, name, city, gender, birth date, profession, set, birth date, change city, display. These two parts together is known as members or features of the object. So that is members or features of the object. This is a simple example of a class and object, person class with 5 different objects. And the class, what is a class? So class is it's a blueprint for various objects of similar types. A class is also a template for multiple objects with similar features. A class describes a group of objects with similar attributes and common behavior. So that is what class is all about. UML, Unified Modeling Language, and Object Management Group. This two full form also you need to remember. And purpose of the class diagram is to model the static view of an application. It is widely used among software developers. And how a class diagram is represented? It is represented using a rectangle split into three parts. The first part is the name of the class, second are the attributes of the class, and third are the behavior of the class. And now we will discuss about UML notation for attributes and UML notation for methods. So UML notation, that is how using UML, how we can describe attributes on paper. So notation, UML notation, an attribute is declared using the syntax given in the green colored second point. Visibility, attribute name, data type, initial value. Now the things which are written within square brackets are optional. That means visibility is optional, data type is optional, initial value is optional. So item written within angular brackets are compulsory. So things written within angular brackets are considered as compulsory. Visibility can be private, protected, public, or package, again indicated by symbols like minus sign, hash symbol, plus symbol, or tilde symbol, tilde tilde symbol, respectively, for private, protected, public, and package visibility. Attributes generally refer to a variable. Attributes are nothing but variables. And the data type and initial value, they identify the type of data stored and its value at the start of the program. So data type decides that what kind of values can be stored in it, that variable, and the value, if we assign some initial value, then it will be taken as the value at the beginning of the program. So this is what the UML notation for attributes. We will be in detail discussing the visibility. So right now you just remember these 4 words, that visibility words. They are private, protected, public, and package. And remember the sign used for representing all these attributes. Next is UML notation for methods. You know that class is made up of 3 things: name of the class, attributes of the class, and behavior of the class. So UML notation for attributes, and now UML notation for behavior or method or function. Whatever we say, it is same. So in UML notation, an operation, a function or method is declared using following syntax. Again, here you see visibility, method name, parameter list, and return data type. Again, here square bracket things are optional, and things written within angular bracket are compulsory, and visibility also same. Parameters, that is what you write in round bracket after the name of the method. So parameter can be specified with data types and optional default value separated by colon, and multiple parameters are separated by comma. So if you see this example, these are parameters here. Set birth date, it has got 3 parameters: D integer, M integer, Y integer, and this is its return type. So that is what parameter and return data type. Now let us discuss about visibility modifiers. Object-oriented programming allows programmers to decide the visibility of attributes and behaviors. A visibility is the scope of the program which can use or modify the attributes and behavior. In simple language, visibility decides whenever it is used with attributes, that is variable, and behavior, that is method. So whenever we use visibility with variables and methods in our program, it decides that which part of the program or the other program can use that variable or method. So we restrict the visibility by different ways. So we have 4 visibility modifiers. So the main purpose of visibility is to protect the data from being misused by the other part of the software, same software, or from outside world, that is from other program, totally other program. There are 4 visibility modifiers: public, package, protected, and private. Public, the widest visibility. When you declare anything, any method or any variable as public, that variable or method is available everywhere in any program, regardless of any program. When you declare any variable, that is attribute, or method, that is behavior, as public, it is accessible by anybody, any program. Package, the second one. Now the visibility we are narrowing down. The public is the widest visibility. Package has got limited visibility. Package visibility allows only specific programs which are coming in one package. only those programs to use that variable or method. So package visibility has limited scope compared to public. Protected. A protected variable or protected method is available where they are defined and its inherited one. Right now you may not understand what is inherited one, but practically we will see it afterward in chapter 7 and 8. So protected members are available in the class where they are defined and its inherited class. And the last, the narrowest visibility is private. Private variables are available only in the class where they are defined and not even outside that class anywhere. So that is the narrowest visibility. Let us understand all these four visibilities with some example. Public. If you see any bench in a public garden, in any public garden if you go and if you see a bench over there, it is public bench. Anybody can go there and sit. There is no restriction that who can sit there and who cannot sit there. So it is a public. Package. The package visibility. Suppose there is a swimming pool in a closed society where there are 6 towers. 6 different towers, and in between they have common facility of swimming pool. Then that swimming pool is accessible or available to those who are staying in that society, not to everybody. If the next society nearby, if they want to come and use that, it is not allowed. It is only allowed to those who are staying in that society. There might be 300 flat owners, then all those 300 flat owners will have access to that swimming pool, but not publicly available. So that is package. Available to many, but to limited. Protected. Protected is something when we borrow something from somebody. Let's say we borrow for one day we borrow a car from our friend. Then it is protected because we don't have right to then give it to somebody else. When we get a car, borrowed a car from our friend, then we don't have right to give that car to somebody else. So that is protected. And private means purely private. For example, your credit card CVV number is purely private, not available to anybody. So that is public, package, protected and private. Public being the widest visibility indicated by plus sign, package being the narrow visibility indicated by tilde sign, protected being again narrower visibility indicated by hash symbol, and private is the narrowest visibility indicated by minus symbol in UML, Unified Modeling Language. Next is encapsulation. Now what is encapsulation? For any program, there are 2 core elements. We have been discussing this point since long. That for any program, there are basically 2 things: data and function, variable and method, attributes and behavior. So these are the 2 core elements for any program. In structured or procedural programming style, that is the previous programming style, previous to object-oriented programming style, views these 2 core elements as 2 separate entities. So in structured programming or procedural programming, data and functions are considered as 2 separate entities. But in object-oriented programming, it views these 2 core elements as a single entity. They don't, like object-oriented programming, they don't look at data and function as 2 separate entities, rather it looks at that as a single entity. In procedural programming, data can be altered, can be modified by any component of the program. So the data in procedural programming are not protected from modification because they are as a separate entity. Whereas in object-oriented programming, this problem can be solved using encapsulation. Here in object-oriented programming, data and methods that manipulate data are guarded against modification or misuse by other components of the same program using encapsulation. So the mechanism of providing protection to data and methods of a program is called encapsulation. This is possible. Now, how encapsulation is possible? So it is possible by wrapping data and methods into a single unit known as class, and then declare that class as private. As we discussed, when we declare any class or any data or any method as private, it is only available where it is defined, nowhere else. So it becomes protected from from the same program and from other programs. So actually what happens in encapsulation is that data and methods, that is variables and methods or functions, they are again wrapped into a unit called class, and that class we declare as private. So it becomes encapsulated. The word capsule is very important here in encapsulation. To understand encapsulation, in medicine we have medicine, like we say capsule, and we know that when we take that medicine capsule, the actual capsule has no meaning. There is no medicine. The actual medicine is kept inside capsule, and capsule is only used to protect that data. So that is what encapsulation. In encapsulation also, we wrap the data, important data, that is all the data and methods, attributes and behaviors, in a class, and then declare that class as private so that it cannot be accessed by anybody from the same program or other program. Private members are not available to others and can be made available only via public method. Thus, encapsulation provides data hiding capability to the programmer. Programmer gets chance to decide that this particular data cannot be accessed by any other part of the program also, and it can be only accessed by the class where they are defined, not even outside that class. So that is what encapsulation. So same thing happens in medicine, that capsule when we are discussing. Even there is another example that when we launch satellite, when satellite is being launched, you know that that satellite is kept inside a capsule, so that when capsule travels outside the atmosphere, there is a high friction, and that friction will be bared by capsule, and satellite will remain safeguarded. So in simple, encapsulation is to provide data hiding capability so that data remains protected. It provides protection to the data and method of a program, and that is why it is called encapsulation. Next, encapsulation keeps data safe from unintended actions and inadvertent access by outside object. So outside object, once you declare your data as private, it is safeguarded from outside objects. Unlike structured and procedural programming, where common data areas are often used for sharing information. Now, because in structured programming, that is the previous style of programming before object-oriented programming, in structured programming, data areas are often used for sharing information with other part of the program, which makes the data accessible by anybody. And object-oriented programming totally discourages the direct access to common data by other program, so that accidentally or intentionally your important data may not be misused. Only the objects that owns the data can change its content. No other object can do. So other objects can only view or change this data by sending message to the owner. They cannot actually modify unless and until owner allows to do that. Whereas in structured programming, any part of the program can manipulate the data, because as we discussed in structured programming, these two core elements are two separate entities, and they are not again kept in any safeguarded in any envelope. Whereas in object-oriented programming, they are safeguarded in a class, within a class, and then that class is declared as private so that data remains protected. Next is data abstraction. Abstraction is a concept that hides the complexity. It says what it does, but don't show how it is being done. So implementation detail is kept hidden. It's something like you say what you are doing. You might be solving a maths problem. So you might tell your friend that I'm solving this problem. Very tough. It may be very tough calculation. But then when you get the answer and when your friend asks that how you solved it, you don't say that how you solved it. So implementation detail is kept hidden. So that is data abstraction. So it's a process of representing the essential features of the objects without including its implementation details. We don't mention that how these things are implemented. We just say that we are doing this, but don't say how it is being done. We saw many places this kind of thing, data abstraction, because it's a technique that relies on the separation of interface and implementation. And we have been using this without realizing it. For example, when you use Excel function is equal to sum A1 colon A10, we know that it will do the total of numbers coming from the range A1 to A10. But how that calculation is done, that implementation detail is kept hidden from user. We know that pressing power button of CPU will turn computer on. But then actually what happens inside when we press power button, that implementation is kept hidden from the user. So that is called data abstraction. A user defined function, like if you define your own function, for example in chapter 2, if you remember, while working with JavaScript, we created a user-defined function validate form to validate the form. Now there was only single line written validate form on submit. Like when submit button is clicked, it will execute this function. So only what over there we mentioned was, okay, when submit button will be clicked, this function will get executed. But what is written in that function was kept hidden at that place. So implementation was kept hidden. So a user-defined function with necessary input data parameters also provides data abstraction. Thus, data abstraction provides the skeleton or templates for our use. It just shows that what it is doing. So the system hides certain details of how data is stored, created, manipulated, and used. All these things are kept hidden. What is visible to the rest of the world is the only abstract behavior of the data type. So that is what data abstraction, where we only see that what it is doing, but we cannot see that how it is being done. So the details about how that behavior is implemented are kept hidden. So it can be modified as per programmer's requirements without impacting other part of the program. So that is what data abstraction. There was an unnecessary word in the last word, that was just to remove that word. Otherwise, that is fine. So that is data abstraction. Still further in data abstraction is this one full form you need to remember, is that is abstract data type ADT, or structures in C, C++, or classes in C++ and Java are the best examples of data abstraction. That when we create a class in Java, we define everything in that class. But then when we create object, we just pass the data from class to object, but we don't show that how it is being done. So that is what abstract data type. In ADT, we simply define a data type and a set of operations on it. We don't show the implementation. So we do not show the implementation of the operation. The basic difference between data abstraction and data encapsulation. Encapsulation protects data. Remember, encapsulation is capsule. It protects the data. Whereas abstraction enables to represent data in which implementation details are hidden. So abstraction is totally different thing and encapsulation is also totally different thing. Encapsulation protects the data and abstraction enables to represent the data in such a way that implementation details are kept hidden. So that is the difference between data abstraction and data encapsulation. What is messaging? Messaging is the meaning is same as what we understand by the word message. A call to a method. See, being a programming, you know that a program contains attributes and behavior. Attributes, that is variable, and behavior, that is method. So a method, when we create method, and to execute that method we need to call that method. So a call to a method is known as a message. So when we write a method and then in our program, when we try to call that method to get executed, so that call is called message. Due to encapsulation, all method calls are handled by objects that recognize the method. So due to encapsulation, like all the method calls, that is all the messages, are handled by objects, all those objects that recognizes the method. Different classes may have same methods with same name. You might have same method name in different classes. So suppose, for example, we have a display method for different classes like date class, person class, time class. All these three classes might be having same method with the name date. Now when this display method is called, how does program understand that which display method is to get executed? So that's a very important point to understand, that when we have same method defined in different class, and when we execute any that method, for example display method, which is available in date class, person class, and time class, and now if I execute display method, how does program know that I mean to say display method of date class, person class, or time class? So that is determined using the object that calls the display method. So now what we understand is, from whichever object we are calling that display method, then it will understand. If I call the display method from the object of date class, it will execute the display method of date class. If I execute or call display method of time class, it will execute the display method of time class, and so on. So when many a class are having methods with the same name, it is determined that which particular method is to get executed from the object from which we are calling that method. Once again, so for example, if display method is called by an object of person class, it executes the display method defined in person class. Date class, it executes the display method of date class, and so on. So call to the different methods of a class to be executed is called messaging. So when we call different methods which are defined in one class, so that calling of that method to get executed is called messaging. Next is polymorphism. Very interesting topic, polymorphism. What is polymorphism? The word polymorphism means different form. So the different form of a single method or operation is called polymorphism. When you define more than one methods with the same name, that is called polymorphism. So polymorphism means many forms. The ability to define more than one method with same name is known as polymorphism. Generally, this is not allowed in every programming language, but object-oriented programming allows you to create more than one methods with the same name, exactly same name. And this capacity or this facility of object-oriented programming, which allows user to define more than one method with the same name, is known as polymorphism. Object-oriented programming allows defining more than one method having same name, but as you know that computer after all is a machine. Software is not a human being. There is no sense in software. Whatever software decision takes, it is because of the programmer. So even though we define more than one methods with same name, but their signature must be different. So if there are more than one methods with the same name in a class, in a single class, then their signature should be different. Now what is signature? We'll see that also. So this feature is known as function or method overloading. So our ability of programmer to define more than one methods with same name, such facility or feature is called function overloading. But there is one more thing to remember is that if you define more than one methods with same name, their signature must be different. Now what is signature we will see, but before that we see the examples of method overloading and operator overloading. Object-oriented programming also allows writing expression using operators on object. So we may use different operators to work with different objects of a class. For example, expression date1 minus date2, where both operands are object of date class. Suppose we have created a date class, and from date class we created two objects, date1 and date2, and then we subtract them by using minus sign. Here operation minus is performed in a different way, totally different way than performing subtraction on two normal numbers like n1 minus n2. In n1 minus n2, the subtraction is done normally as we do in our mathematics. But when that subtraction sign is used with date object, and date object subtraction will be done differently. Over there you give two different dates, it will subtract those dates and gives the days coming in between two dates. So that is, here subtraction is done differently. So the same operation or the same operator, that is minus sign, is given different meanings depending upon the data type of operands which are used in the expression. This type of polymorphism is achieved through operator overloading. So when a single operator is used for two different purposes, it is called operator overloading. But remember, Java does not support operator overloading. Java do support method overloading, but Java is not supporting operator overloading. Thus, polymorphism is achieved using two types of overloading, and that is function overloading and operator overloading. But as I said, Java does not support operator overloading. So in general, the capacity of using same names to mean different things in different contexts is called overloading. Now, as I said, that this is the example, we will see this example also, but before that, as I said, that the signature should be different. Now what is signature? So we can see that signature here. Signature of a method consists of three things. Name of the method, as you can see here, the method name is println, println, println. Second, return type of the method, which is here static void, static void, static void. And third, parameter of the method, which is here 0, there is no parameter. Here there is one parameter, integer n, and here there are two parameters, character ch and integer n. So this method overloading, that is polymorphism in Java, is only possible if the signature of the method is different. And signature means any one of the three things should be different. Either the name should be different, which is same here, as you can see, println, println, println. Return type should be different, which is again same here, static void, static void, static void. Or parameter should be different, which is different. Here, this first method has got 0 parameter, second method has got 1 parameter, third method has got 2 parameters. So that is what polymorphism. Now, compiler will not get confused when we call, as you see here, println without any argument. Compiler understands that this will has to execute the first method, println into bracket 30 computer will understand, compiler will understand that it is supposed to execute this second method. And when we say println plus comma 20, compiler will understand that it is supposed to execute this third method with two parameters. So that is what the signature of the method should be different. So this is the example of polymorphism. One more thing you need to understand in this program, though this program comes in 8th chapter, but because it is more relevant here, so I had taken this here, the screenshot. One more thing you understand is, if you see the name of the class is println and name of the method is also println. But remember, the class name and these method names are totally different. There is no comparison because class name, as you see, println is with P capital, L capital, whereas method names, everything is written in small letter. So it is as good as two different words, only their pronunciation is same. So don't get confused with that also. Though this thing will come in 8th chapter, we will discuss that time also. But you should know that, okay, this print line, that is the name of the class, and this print line, which is name of the method, are different. So that is polymorphism, aggregation and composition. What is aggregation and what is composition? The last topic of chapter 6. See, when objects of one class is composed of objects of different other classes, it is called aggregation or composition. So when we take object of different classes and then from that we define another object, that is called aggregation or composition. Aggregation composition represents has a or a part of kind of relationship between two classes. So there is exist has a or a part of kind of relationship. For example, motherboard is a part of computer or computer has a motherboard. So the relationship between motherboard and computer is aggregation composition or composition. When we define class computer, it will contain attributes that are object of class motherboard and screen. So thus it implies containment. So aggregation composition implements containment. So computer is made up of so many other things. Apart from motherboard, there can be monitor, there can be keyboard, there can be mouse, there can be memory, there can be DVD drive, SD drive, SSD drive. There can be so many things. So motherboard is just one part of computer. It is not the entire computer. So that is aggregation and composition, which indicates has a or a part of relationship. The example here in person class, we have taken objects of name class, as you can see here, nm. Nm is object of name class and addr is object of address class. So the data type of nm is name, as you can see here. Over here, gender is character, birth date is date type, profession is string type. But nm is of type name, addr is of type address. So the data type of nm is name and that of address addr is address. Thus class person contains object of class name and address, and this is called aggregation or composition. Now let us see the difference between aggregation and composition. Aggregation and composition. Aggregation represents non-exclusive relationship between two classes. It represents non-exclusive relationship between two classes and it is indicated by an empty diamond symbol. In aggregation, the class that forms part of the owner class can exist independently. So the relationship between both the class is not exclusive. Both the class can exist on their own independently. For example, address class and person class, they are not strongly related, they are having non-exclusive relationship. So the life of an object of the part class is not determined by the owner class. For example, though a motherboard is a part of computer, it can exist as a separate item. Similarly, object address may be shared by more than one person. So address is not exclusively associated to any one person, as you can see here, and as just now I showed you. Address, though, is part of person class, but it is not associated with person class exclusively, because the same address might be shared by many person. So it is not exclusively associated with this, but name is exclusively associated with person. We'll see that. So I hope you understood first aggregation. Aggregation is non-exclusive relationship between two classes, and they are indicated by empty diamond symbol. Composition. Composition represents exclusive relationship between two classes, and it is indicated by filled diamond symbol. Remember, aggregation is indicated by empty diamond symbol, and composition is indicated by filled diamond symbol. Aggregation is non-exclusive relationship. Composition is exclusive relationship. Composition is a strong type of aggregation where the lifetime of the part class depends on the existence of the owner class. If the owner class is there, then only the part class can exist. Otherwise, it cannot exist on its own. So if an object of aggregating class is deleted, its part class object also gets deleted. So for example, when object of class person is deleted, the object of class name is also deleted, as you can see here. Now if we create an object of this person class, then if that object is deleted, then the name is also deleted, because they are related to each other strongly, and that is composition. So for example, when object of class person is deleted, the object of class name is also deleted. So name is associated exclusively with single person. So they have the bonding exclusive relationship, so that if name class is deleted, person class will also not exist, and person class is deleted, name class, the part class, also gets deleted. So that is a strong aggregation, and a strong aggregation is called composition, represented by filled diamond symbol. Composition and aggregation. Now, the class that contains object of other class is known as owner class or whole class or aggregating class. Remember these three words for composition and aggregation, because board is quite often asking these questions related to this. So once again, the class that contains object of other class is known as owner class or whole class or aggregating class. For example, person class. Person class contains the object of other class like name class and address class. So that person class is called owner class, whole class or aggregating class. Second point, the class that is contained in owner class is known as subject class or part class or aggregated class. For example, name and address class. So name and address class are contained in owner class. So they are called subject class, name class and address class are called subject class, part class or aggregated class. So that is what composition and aggregation. And the last topic of chapter 6 is inheritance. Very interesting to understand inheritance. Inheritance is generally referred to as is a kind of relationship between two classes. Now remember, aggregation composition is what kind of relationship? A part of or has a type of relationship. Has a or a part of type relationship. Whereas inheritance is a kind of relationship between two classes. It is appropriate when one class is a kind of other class. For example, a teacher is a kind of person. So all the attributes and methods of class person is also applicable to class teacher also. Let us take other example. An engineer is also a person. So an engineer class is a kind of person. So all the attributes and methods of class person is applicable to class engineer also. Apart from that, from normal person, engineer will have something extra also, which every normal person will not be having. Those things we add in the new class, engineer class, and that is called inheritance. So in short, class teacher inherits all attributes and behavior of class person. Or for as our example, class engineer inherits all attributes and behavior of class person. Class teacher may also have some additional attribute. Similarly, for our example, class engineer may also have some additional attributes. For teacher, it may be like subject and methods, like taking lectures of the subject. For engineer, it may be like specialized subject, area of application of the knowledge, like કયું engineer છે કયા એરિયામાં એનું knowledge apply કરે છે, those things. In such scenario, class teacher can be defined using class person. We don't need to define teacher class from scratch. If we now understand this, uh, with our example, we'll understand this. Let's suppose I have person class defined, and now I want to create doctor class. Remember this example and try to understand this. I have a class defined with the name person, where there is name, date of birth, gender, city, and something like this, birth date and other things. Now I want to define doctor class. Now doctor is a person, or doctor is a kind of person. So look here, it shows the relationship of is a kind of, that means inheritance is possible. So what object oriented programming says, that you don't need to create doctor class from scratch. You can take the person class into doctor class, inherit the person class into doctor class, and then add new features in the doctor class which is not in the normal person class. That is called inheritance. Inheritance refers to the capability of defining a new class of objects that inherits the characteristics of existing class. So you have existing class and you inherit everything of that existing class into new class and then add new features in that new class. So in object-oriented terminology, the new class which we define is called subclass or child class or derived class. Remember, the word is subclass, child and derived, but the inherited class will always have something more than parent class. Whereas the existing class is called superclass or parent class or base class. So even though the word is super, parent and base class, but it will have less information than subclass or child class or derived class. So subclass or child class or derived class will always have something more. For example, person class is our base class, parent class, and then we are creating doctor class from that by inheriting. So doctor class will always have something more than normal person. So that is what inheritance. The data attributes and methods of superclass are all available to objects in the subclass without rewriting their declarations. So everything what is there in the superclass, when you do inheritance, everything comes to the child class without any thing rewriting. This feature provides reusability where existing methods and attributes can be reused without redefining. Additionally, new data and methods can be added to the subclass as an extension. So inheritance also allows the method to be redefined in subclass as per need. If there is a method defined in parent class or base class, using inheritance in subclass, we can rewrite those methods with new features. So in class diagram, inheritance is represented using an arrow pointing towards superclass. So as you can see here, this is superclass, person class is superclass or the base class, and teacher is the inherited class. But remember, though it shows small, but when you do inheritance like this, everything, this name, city, gender, birth date, profession, set birth date, change city, display, everything is available now in teacher also. And apart from that, there is more things like subject, lecture, display. This is something new which is in the teacher class and not in person class. But while defining teacher class, we don't need to create all these things again. We do inheritance, and all these things are available in teacher class. So that is inheritance. Generalization is yet another name for inheritance, or is a kind of relationship. So it is also known as generalization. It refers to a relationship between two classes where one class is a specialized version of another class. Common attributes and methods are defined in superclass. As you can see here, common method and attributes are defined in superclass. Subclass is a specialized version of with some additional features. So these are some additional features of subclass, that is teacher class. A class can also be derived using more than one parent classes. That is also possible. For example, a child inherits characteristics of mother as well as father. Airplane is a kind of vehicle as well as flying object. So a class can also be derived using more than one parent classes. And when a class is derived from two or more classes, it is known as multiple inheritance. And this is multi-level inheritance. So sometimes there may be a classical hierarchy of inheritance between classes. Here it is inheritance, but in is skipped. So it is inheritance here. So sometimes there may be a classical hierarchy of inheritance between classes. As you can see here, employee is a kind of person and teacher is a kind of employee. So this is the classical hierarchy. Teacher is inherited from employee and employee class is inherited from person class. So for example, class employee can be derived from class person, and then class teacher can be derived from class employee. So here employee is a kind of person and teacher is a kind of employee. So this is called multi-level inheritance. And the last thing, composition versus inheritance. What is the basic difference between both of them? In composition, classes do not inherit from other classes but are composed of other classes. Remember, they are not getting inherited from other classes, but they are composed of different classes. So class contains the attributes where some attributes are object of other class types. So here in composition, class contains the attributes where some attributes are of different objects. Whereas in inheritance, class inherits from another class in order to share, reuse, or extend the functionality. Here there exists a kind of relationship between superclass and subclass. So that is what composition versus inheritance. Sixth chapter, I will request you to go through 2-3 times because all the new concept, though chapter is very small, but there are so many concepts, so it took more time for me also to explain all these topics, and you will also understand these topics once you read this and listen to these videos 2-3 times, especially all these topics, new topics, like right from encapsulation. Here visibility modifiers also is very interesting. 4 visibility modifiers: public, package, protected and private. And encapsulation, data abstraction. Encapsulation provides the security of your data. Your data is secured, so that you declare that, create a class and then declare them as private so that they are secure. So encapsulation keeps data safe, whereas abstraction is a concept that hides the complexity of the programming. It says what it does but not how it is implemented or how it is done. So that is data abstraction. Messaging is call to a method or a function which we have defined. Calling that function or method is called messaging. Polymorphism, many-form, creating multiple methods with the same name but with different signature. Signature is made up of 3 things: name of the method, return type of the method, and parameters of the method. So something should be different, either name should be different, or return type should be different, or list of parameters should be different in polymorphism. Polymorphism can be achieved using two types of overloading: function or method overloading, and second, operator overloading. But as I said, Java does not support operator overloading. So that is polymorphism, aggregation, and composition. It represents has a or a part of kind of relationship between two classes. So motherboard is a part of computer. So that is aggregation, composition. Again, the difference between aggregation and composition is aggregation represents non-exclusive relationship between two classes and indicated by empty diamond symbol. Composition is represented exclusive relationship between two classes and indicated by filled diamond symbol. If an object of aggregating class is deleted, its part class object also gets deleted. If such type of relationship is there, it is called composition. And if the part class can exist on its own, then it is aggregation. As you can see here, one relationship is aggregation relationship, that is the relationship between person and address, because the address may be shared by many persons. Your address may be shared by your mom, your dad, your grandparents, your brother, your sister, and everybody, those who are living in your same house. But name, your name is not shared by anybody. It is your personal name. So that is strong relationship, composition. And address and person is weak relationship or non-exclusive relationship, that is aggregation. And last we saw inheritance is generally referred as is a kind of relationship. When a new class which we want to create is a kind of existing class, we say inheritance. Like engineer is a person. So if we have person class defined, we don't need to define engineer class from scratch. We can inherit person class into engineer class and then add new features in that. So that is what inheritance. In inheritance, new class which we inherit is called subclass, child class, or derived class, and the class from which we are inheriting is called superclass, parent class, or base class. So that is inheritance shown with the arrow pointing towards parent class. And generalization is again another name for inheritance. It's a specialized version of existing class. Multi-level inheritance, as you can see, the teacher class is inherited from employee class and employee class is inherited from person class. And then last we saw the difference between composition and inheritance. Thank you for watching. Take care. Do read this chapter, listen to this chapter as many times as you can so that rest of the chapters would be easy for you to understand. Thank you. Bye bye.